last topic, 3.7, applying the exponent laws. So this includes the two that we've learned in 3.5 and 3.6 regarding fractional and negative exponents, plus everything we've learned from grade 9. So just a quick reminder on what all of these laws are. The product of powers says that a base a to the power of m times the same base, that's key here, to the power of n is equal to a to the m plus n. So for example, if we had 7 cubed times 7 to the power of 4, this would be 7 to the power of 3 plus 4, which is 7. Okay, the quotient of powers is a to the m, again, all over a to the n. Now, again, they're the same base, a and a. This time, we are subtracting m minus n. Okay, the thing is here, a cannot equal 0. Otherwise, what happens is we get a denominator that is 0 here, and that can't happen. We can't divide by 0. The power of a power is a to the power of m all to the power of n. What happens here is we get a to the m times n. So for example, if we have, 7 to the 3 now to the power of 4, this is 7 to the 3 times 4, which is 7 to the power of 12. I forgot one over here for the product or quotient of powers. If we have 7 to the 7 all over 7 to the 4, we get 7 to the 7 take away 4 is 3. Power of a product. In this one, if we have a times b all to the m, we can write this as a to the m times b to the m. Power of a quotient. So if we have a all over b all to the power of m, just like m applied to everything within our brackets here, m applies to everything within our brackets in our fraction. So a to the m all over a to the n. Okay, where b can't equal 0 here. Otherwise, again, we get a 0 in our denominator. The last one, law of fractional exponents, is x to the m over n. This is on the back side of your notes. Is equal to the nth root of x to the power of m, or the nth root of x all to the power of m. Lastly, don't forget that if we have x to the negative, I guess I should say a to the negative n, this is the same thing as 1 over a all to the n, which would be 1 over a to the power of n. Okay, so just looking at all of those, we're going to put them into action here. So 0.8 squared times 0.8 to the negative 7. This is a product of powers. So we have the same base, 0.8 in each. They're being multiplied, so that means we're going to add their exponents. So this will be 0.8 all to the 2 plus negative 7. 2 plus negative 7 is negative 5. Now the last thing we want to do here is we might want to write this as a positive power. So we could say that this is also equal to 1 over 0.8 all to the power of 5. Okay. All right, this one looks complex, but we can simplify. This is a power to a power. Okay, so we have negative 4 over 5 all squared. And then all of that is to the negative 3. So I'm going to multiply these two powers together in both cases. So I'm going to get negative 4 over 5 all to the power of negative 6. And that is divided by negative 4 over 5 all to the power of negative 20. Now remember, because we are dividing, we are subtracting here. So we get negative 4 over 5. Now negative 6 take away negative 20. A negative and a negative becomes a positive. So we end up with negative 4 over 5 all to the power of positive 14. These are a few more of example 1. We have 1.5 cubed all to the power of negative 5, all divided by 1.5 to the power of 5. Now note that they're all the same base here. So I'm going to multiply these two first. So I'm going to get 1.5 all to the power of negative 15 divided by 1.5 to the 5. So I'm subtracting powers because now they are a quotient. Okay, so dividing. So 1.5 to the negative 15, take away 5, I get 1.5 to the negative 20. Now that is giant. When I have fractions like this, decimals, I might want to turn it into fractions. So I might want to say that this is 3 over 2 all to the negative 20. Now, because we have a negative, we'd like to express it as a positive. That would be the reciprocal of this. So 2 over 3 all to the power of positive 20, which is giant. Okay, this one, we need to take care of bed mass. Now, because this is all divided, so our numerator, our top, is all divided by one factor, it's like we need to treat this as a bracket. So we're going to take care of the top and combine it into one term and then divide if possible. They all have the same base of 9, so that will work. So 9 to the power of 5 over 4 times 9 to the negative 1 over 4. So we're going to add these two exponents. So 9 to the 5 over 4 plus negative 1 over 4 is all over 9 to the 3 over 4 still. 5 over 4 plus negative 1 over 4 brings us to 9 to the power of 4 over 4. Because they already have the same common denominator, we don't need to work on that. And that's still over 9 to the 3 over 4. Now I could simplify 4 over 4. However, I know I need to subtract my next two exponents, and they have to have the same common denominator. So I may as well just leave it as a 4 over 4 here, because this will become 9 to the 4 over 4, take away 3 over 4. And that is 9 to the 1 over 4 as our final answer. Remember, we could write this as the fourth root of 9. We were asked to write it as a single power, though, so that's probably not where we want to take this one. All right, our last example, there's just a ton of them, so I'm going to go through each just so we get lots of practice together. So m to the 4, n to the negative 2 times m to the 2, n to the 3. It doesn't matter the order here. Everybody's being multiplied, so I may as well rearrange. So I put mine as m to the 4 times m to the 2 times n to the negative 2 times n to the 3. Just to group like bases here. M to the 4 times m to the 2, we are adding exponents because they're just being multiplied here. So that would be m to the power of 6. N to the negative 2 times n to the negative 3, we add exponents here, and that would be just n to the power of 1. So negative 2 and 3 is positive 1, and I don't need to write the 1 there. All right, this one looks a little complex. We have numbers, and we have two variables here. So remember, we just need to work within the same base. I'm going to take care of the numbers first. So 6 over 14 can be reduced. Each number can be divided by 2. So I'm going to write this as 2x to the 4, y to the negative 3, oopsie, all over 7x y squared. Just reducing those. Oopsie, that should be a 3 if I'm dividing both by 2. Okay, then I'm going to look at my exponents here for x and y. Now they're being divided, so I'm going to subtract their exponents. X to the power 4, and I need to take away the exponent here. Remember, this is just x to the power of 1. So x to the 4, take away 1, we are going to get 3 over 7. And x to the 4 take away 1 is x to the power of 3. Now I'm going to do the exact same thing for y. Y to the negative 3 take away 2 is y to the negative 5. Now, we have a negative exponent here. So, to make it positive, I just need to take it to the bottom of my fraction. It's like saying we have y to the negative 5, all multiplied by some fraction. 1 over y to the 5 times my fraction, we'll just put y onto the denominator. So my final answer here is 3x cubed all over 7y to the positive 5. Okay, 25, a to the 4, b to the 2, all raised to the 3 over 2. So what I did first is I took out the number and I left it by itself. So I said that this is 25 to the 3 over 2 times a. Now this is multiplied here, so this is a to the 4 times 3 is 12 all over 2. Okay, again it's 4 times 3 over 2. This is technically over 1, therefore we get 12 over 2. Now b is 2 times 3, which is 6 over 2 as well. All right, now we can write this as 25 squared, or sorry, square root of 25, all cubed. Okay, using our fractional exponents rule. Times, now a to the 12 over 2 is a to the 6, and b to the 6 over 2 is b cubed. 25 squared is 5. 5 cubed, oopsie, a to the 6, b cubed. 5 cubed is 125, so we have a to the 6 still times b cubed. All right, x cubed, y to the 3 over 2 times x to the negative 1, y to the 1/2. Again, these are all just multiplied. I can't combine anything or do anything using BEDMAS within our brackets, so we may as well just get rid of our brackets. With doing that, I'm going to regroup so that my x's and y's are next to one another. So x cubed times x to the negative 1 times y to the 3 over 2 times y to the 1/2. So x cubed times x to the negative 1 is 3, x to the 3 plus negative 1, which is x squared. Times, we need to add these two terms. So 3 over 2 plus 1 over 2 is 4 over 2. We can simplify to x squared times y. 4 divided by 2 is squared. Last two here. 12x to the negative 5 times y to the 5 over 2 divided by 3x to the 1/2, y to the negative 1/2. So my first step was to divide 12 by 3, just to get rid of the values or reduce. So we can get that to 12. 4x to the negative 5, y to the 5 over 2, all over x to the 1/2, y to the negative 1/2. Now, we are using our quotient rule, so we're going to subtract the exponents. So, negative 5, take away a half. Now, I'm going to turn negative 5 into a fraction. So that becomes negative 10 over 2. We can agree that negative 10 divided by 2 is still negative 5. And we're going to subtract 1 over 2. That leaves us with negative 10 take away 1 is negative 11 over 2. That'll be our exponent for x. Again, because we had x to the negative 5, take away 1/2. So, for x to the negative 11 over 2. Notice that my answer to our quotient rule, where we're subtracting, always goes on the top to begin with. Okay, we have another fraction here. So 5 over 2, take away negative 1/2. Don't forget about these negatives. A negative and a negative here make a positive. So I'm going to be left with 6 over 2, which we can simplify to 3. So this is going to be y cubed. All right, getting rid of our negative, we just want to take it to the bottom of our fraction. Okay, which is technically over 1 now, so I'm just going to say that this is 4y cubed. Taking x to the denominator will make this a positive. Last one. Okay, so 50x squared y to the power of 4 divided by 2x to the 4 y to the 7, all raised to the 1 over 2. So we could disperse this 1 over 2 to everybody in here, but I could simplify it, and it belongs to everybody on the bottom too, don't forget. But what I'm going to do is I'm going to simplify first. Okay, so I am going to apply my quotient rule within the brackets, and then I'm going to apply my exponent. So 50 divided by 2 is 25. Oops. X to the 2, take away 4. It leaves me with x to the negative 2. Y to the 4 divided by y to the 7. I'm going to say that is y to the power of 4 take away 7. And that gives me y to the negative 3. This is all still, oopsie, to the 1 over 2. So we can apply our 1 over 2 to everybody here if we'd like. So 25 to the 1 over 2 times x to the negative 2 times 1/2 is negative 2 over 2 times y to the 3 times negative 1, or sorry, times 1/2 is negative 3 over 2. Okay, remember that 25 to the 1/2 is square root of 25 times x to the negative 2 over 2 is negative 1, and we can't really simplify y. Okay, we have two negative exponents here again, so I'm going to move those to the denominator, and in the same time I am going to simplify my 25. So the square root of 25 is 5. It stays up at the top, and I'm moving my x and my y to the 3 over 2 to the denominator. Just looking up here at my notes again, I'd made an error, so I will try and upload those again right away to correct that. I'd say pause the video here and try this exit task. What we end up with is x to the 1 over 2 times, y times x to the 3 over 2, y to the negative 2. We add the exponents of both x and y. So we get 4 over 2 is the exponent for x, and 1 plus negative 2 brings us to negative 1 for y. 4 over 2 is x squared divided by y to get rid of our negative.